First, thank the organizer for this precious opportunity. I'm Xiaoxuan Xia, a postdoc from the Department of Statistics of the Chinese University of Hong Kong. Today, I would like to introduce my research, which is called Bayesian Inference of Local Genetic Correlation. This is the joint work with my supervisor, Dr. Ying Wei, and our collaborator, Dr. Lin Hou from Tsinghua University. The genetic correlation quantifies the genetic similarity of two traits, and thus it has important applications in variant identification, risk prediction, and causal inference. The overall genetic correlation measures the average correlation of genetic effects across the genome, and the local genetic correlation focuses more on specific genetic regions. Although the estimation of the overall genome-wide genetic correlation have become routine for GWAS analysis, however, statistical methods that provide robust estimation of local genetic correlation are still lacking. There are mainly three challenges remain for local genetic correlation estimation. First of all, the genetic effects and hence the local genetic correlation can be very heterogeneous across the genome. And secondly, due to the noisy estimation of genetic effects, the heritability of some region can even be estimated to be negative. And this would make the inference of genetic correlation impossible. Finally, LD pattern among SNPs and the computation required for the large number of SNPs is the third challenge. Here we propose a statistical method Bayesian inference of local genetic correlation, abbreviated as BALOC, to estimate the local genetic correlations. Since BALOC models all the SNPs together, it is able to borrow information across the genome, across the whole genome. Specifically, we model the phenotype Y1 and Y2 by the sum of genetic contributions from block 1 to block capital K, where the XKJ is the matrix of genotype, and we usually scale the columns of this XKJ before we conduct further analysis. And bit kj is the vector of marker effects in block K for phenotype J. When a LD block K is causal for both traits and correlated, we assume the vector of beta K1 and beta K2 follow a normal distribution, with rho K being the local genetic correlation that we are interested in. We use chromosome 22, which contains about 6,000 SNPs from 47 LD blocks for simulation, and we randomly choose 5,000 individuals from UK Biobank. To simulate the phenotypes, we set the heritability to be 0.8 for both traits. Specifically, we set a sparse causal model, and we randomly select 15 regions to be genetic correlated. From figure 1, we can see that BALOC estimates much more accurate than the state-of-art method SuperGenova. Specifically, the Pearson correlation between the estimated row and the true row is 0.9 for BALOC and is about 0.1 for SuperGenova. Besides, the AOC of identifying correlated regions for BALOC and SuperGenova is 0.958 and 0.644 respectively. BALOC computes efficiently. It takes BALOC about 7 minutes to finish the computation using 2 cores under this setting. We then apply BALOC to infer potential genetic correlation between BMI and height on chromosome 16. Chromosome 16 is well known for hosting SNPs of significant associations with BMI. And BALOC totally identified 37 genetic correlating regions at a false positive rate of 0.05. However, supergenova failed to detect any significant correlations, and this could be seen in Table 1. So Table 1 lists out the top 5 regions ranked by the p-value of supergenova. And from this column, we can see that the smallest p-value is 0.055, which is still not significant. And we further find that these regions identified by BIOC contain genes, for example, XYLT1, FTO, etc., which are related to metabolism pathways. In summary, here we propose a statistically robust and computationally efficient method for estimating local genetic correlations. And we are currently working on genome-wide correlation exploration and further implementing summary statistics. And we hope you will find our work useful or interesting. Finally, we would thank the support of general research funds from Hong Kong Research Grants Council and direct grants from CUHK. Thank you for your attention.